Hi everyone, this is Dr. D.Amsaveni, Associate Professor, PG and Research Department of Mathematics, Sri Sharada College for Women, Salem. This video, I am excited to share my knowledge about the characteristic function and their properties in mathematical statistics. Let's start this topic by recalling moment generating function. The moment generating function of a random variable x is a function from R to R, which is defined as mx of t is equal to expected value of e power t x, t belongs to R. For discrete random variable, the moment generating function is for a discrete random variable, the moment generating function is mx of t is equal to summation e power tx p of x, where p of x is the probability mass function. For continuous random variable, the moment generating function is mx of t is equal to integral minus infinity to plus infinity e power tx into f of x dx. Here, f of x is probability density function. If you determine the moment generating function for both discrete and continuous random variable, so this may not converge, and then moment generating function does not exist. In this situation, we can have another function which is called the characteristic function. The characteristic function of a random variable x is denoted by pi of t and is defined as pi of t is equal to expected value of e power itx. T belongs to R. A characteristic function is a function whose domain is R and whose range is C. T is a real number, I is the imaginary unit. If x is discrete type with the jump points xk, if x is discrete type with the jump points xk and corresponding probabilities pk, then the characteristic function then the characteristic function is given by pi of t is equal to summation k e power I t x k p k. If x is continuous, x is the random variable, so continuous random variable with the density function, f of x, then the characteristic function is given by pi of t is equal to integral minus infinity to plus infinity e power I t x into f of x dx. Let's see an example for finding characteristic function of the random variable. Given that the random variable x takes on the values minus 1 and 1 with the probability value 0.5, and find the characteristic function of the random variable x. We know that the characteristic function of the random variable, which is of the discrete type, is pi of t is equal to summation over k e power I t x k into pk. Now, this xk takes the values minus 1 and 1. This pk takes the values 0.5. Substitute here and sum it. So e power, when xk takes the values minus 1, it will be minus it into pk is 0.5 plus, if xk takes the values 1, then it will be e power it into 0.5. Now 0.5 is common, so this into e power minus it plus e power it 0.5 into, so e power minus it plus e power it divided by 2 is cos t. Here e power minus it plus e power it is 2 cos t. Hence 2 into 0.5 is 1, then we get cos t. So this is the characteristic function of the random variable x, which is of the discrete type. So next let us see the finding the characteristic function of the random variable if it is continuous type. The density f of x is given here, and we now determine the characteristic function. And we know the characteristic function of the random variable for the continuous type. So that is pi of t is equal to integral minus infinity to plus infinity e power I t x into f of x dx. Here f of x takes the value 1, others are 0. Okay, so we take this function only. Here minus infinity to plus infinity, sorry, the limits varying from 0 to 1 for this function. So 0 to 1 e power I t x, f of x is 1, therefore dx. And then integrate with respect to x. So e power I t x by I t, the limits are 0 and 1. Then substitute the upper limit first. So e power I t into 1, that is e power I t divided by I t minus, if we substitute the lower limit, will be e power 0 by it. So which is equal to e power it minus 1 by it. This is the characteristic function of the random variable, which is of the continuous type. So next we see the some properties of characteristic function. Pi of 0 is equal to 1 and modulus of pi of t is less than or equal to 1. That is the characteristic function bounded by 1. Then third property, pi of minus t is equal to pi of t the whole bar. It's a conjugate function. So let us see one by one. So pi of 0 is equal to 1. And from the definition, pi of t is equal to the expected value of e power itx. So here t is equal to 0. So we substitute t is equal to 0 in this function. Therefore, expected value of e power 0 which is equal to e power that is expected value of 1, so which is 1. Then second property, modulus of pi of t is less than or equal to 1. So from the definition, modulus of pi of t, from the definition, first we write the definition. Pi of t is equal to expected value of e power itx, and taking modulus pi of t is equal to modulus of expected value of e power itx. This is less than or equal to expected value of modulus of e power itx, and this is equal to e of, that is expected value of 1, since modulus of e power itx is equal to 1. So expected value of 1 is 1. Therefore, modulus of pi of t is less than or equal to 1. Then next one is pi of minus t is equal to conjugate of pi of t. Again, from the definition, pi of minus t is equal to expected value of, so pi of t, we know that expected value of e power itx. Here pi of minus t, replace t by minus t. So therefore minus itx, so which is equal to expected value of cos by Euler's formula. It can be written as cos itx minus I sin tx. Sorry, this is tx. It would come. So cos tx minus I sin tx, which is equal to expected value of cos tx minus I into expected value of sin tx. This implies, and then so next we find this one and we equate these two. So pi of minus t is equal to expected value of cos tx minus I into expected value of sin tx. Next we find pi of t bar. which is equal to pi of t is the characteristic function, the expected value of e power I t x, and the bar. Now this can be expanded by using the Euler's function. So that is expected value of cos tx plus I sin tx, the whole bar, and this will be written as expected value of cos tx plus I into expected value of sin tx, the whole bar. So which is equal to expected value of cos tx minus I into expected value of sin tx. Therefore, so compare these two results, that is pi of minus t is expected value of cos tx minus I into expected value of sin tx, and also pi of t the whole bar is equal to, get the same result, expected value of cos tx minus I into expected value of sin tx. So from these two results we conclude that pi of minus t is equal to pi of the conjugate of pi of t. So we have proved all these properties. The next one is the characteristic function and the moments. The nth moment is denoted by L if the nth moment of the random variable exists and the nth moment is expressed by ml is equal to pi L of 0 by I power L. So here pi L of 0 is the derivative of the characteristic function pi of t of the random variable at t is equal to 0. This is an example for finding the characteristic function of x and its moments. The random variable x, which has the Poisson distribution and can take on the values xk is equal to k. K is any non-negative integer and the probability function is given by the formula e to the power minus lambda, lambda power k by k factorial. Lambda is a positive constant. Okay. So we know the characteristic function phi of t is equal to expected value of e to the power itx, which is equal to summation over k e to the power itxk into pk if the random variable x is of the continuous type. And summation k e to the power itk, pk is xk takes the value k and pk is the function e power minus lambda into lambda power k by k factorial. So e power minus lambda will be outside since it won't affect the value of k. So summation e power itk lambda power k by k factorial. And after we are going to expand this function by giving the values for k. K takes the values 0, 1, 2, 3, etc. So if k is equal to 0, then we will get 1. If k is equal to 1, we will get lambda into e power it by 1 factorial. If k is equal to 2, lambda squared into e power it the whole squared by 2 factorial plus etc. We know that, so it is e power x is equal to 1 plus x by 1 factorial plus x squared by 2 factorial plus etc. This is of the form e power x. Therefore, this will be written as e power minus lambda into, here x is lambda into e power it, lambda into e power it. Then e power minus lambda plus lambda into e power it, adding the powers. Then lambda can be taken outside, then we get e power it minus 1. So this is the characteristic function of the random variable which has the Poisson distribution. Next we find the moments. So already we discussed earlier, Lth moment is denoted by ml and which is expressed by the formula pi L of 0 by I to the power L. Here pi L of 0 is the derivative of the characteristic function pi of t of the random variable at t is equal to 0. Now we are going to find the moments of the Poisson distribution. So I write the formula first, pi L of 0 by I to the power L. So we need to find the moments m1, m2, etc. So m1 is equal to get m1, put L is equal to 1. So pi 1 of 0 by I. So we need to find the first derivative, second derivative, etc. So, and we have the characteristic function e power lambda into e power it minus 1. So pi dash of t means finding the first derivative. We have to differentiate this function e power x. So the derivative of e power x is e power x. After that, if any function, if there is any function instead of x, we have to differentiate it again. So lambda into e power it minus 1 can be differentiated here and put write the answer here. So lambda into e power uh, sorry lambda into e power it into I. Now put t is equal to 0 to get pi dash of 0. Okay, so pi dash of 0 is equal to, so if we substitute t is equal to 0, so this will become 1. So 1 minus 1 is again 0. So 0 into lambda is 0. So e power 0 is 1. And then here also 1. Therefore we get lambda I. Now m1 is equal to pi dash of 0 by I. We substitute pi dash of 0 is lambda I by I, which is equal to lambda. And m2 is equal to pi double dash of 0 by I square. We need to find pi double dash of 0. First, first to find pi double dash of t, now we differentiate this function again. So here lambda I into this function is lambda I into, first I write function pi of t, e power it into e power lambda into e power it minus 1. This is our pi dash of t. Now pi double dash of t is equal to lambda I into, this can be differentiated by using the formula uv. So u dv u lambda into e power it into I u dv, this is u v. So u dv plus v du. So e power it minus 1 into e power it, differentiate e power it, so you will get e power it into I. And pi double dash of 0, to find pi double dash of 0, so we substitute t is equal to 0 here. So when we substitute t is equal to 0, this will be 1, and here this is also 1, this is also 1. Again we are getting lambda I into lambda I plus, here also we get e power, this is 0, so e power 0 is 1 into I. So we get I. Multiplying lambda square into I square plus lambda into I square. Therefore, m2 is equal to pi double dash of 0 by I square. Now we substitute lambda squared plus lambda I square by I square. So I square will get cancelled by I square, which is equal to lambda squared plus lambda. Now finding the variance formula is m2 minus m1 square, which is equal to m2 is lambda squared plus lambda minus m1 squared is m1 is lambda. m1 squared is lambda squared, which is equal to lambda. This is variance. So the variance of the Poisson distribution is lambda. Here we find the characteristic function and moments of normal distribution f of x, which is given by 1 by root 2 pi e power minus x squared by 2. And also we are proving that all the odd order moments equal 0 and that the even moments are expressed by m2l is equal to 1 into 3 into 5 etc. 2l minus 1. Let us see the solution. Pi of t is equal to the characteristic function, which is integral minus infinity to plus infinity e power itx into f of x dx. Here f of x is given here, so we substitute here. Therefore, integral e power itx into 1 by root 2 pi e power minus x squared by 2 into dx. 1 by root 2 pi will be outside, then integral e power itx e power minus x squared by 2 into dx. 1 by root 2 pi integral e power, so from this can take minus 1 by 2 outside and then we will get x squared minus 2itx into dx. Now in this we are adding add and subtract it the whole square. Therefore, x square minus 2itx plus it the whole square minus it the whole square. We are adding and subtracting it squared into dx. Which is equal to root 2 pi integral e power minus 1 by 2. We are combining these three terms and we write x minus it the whole square into, this is e power, so 1 minus 1 by 2 into minus it the whole square. So it will give e power minus t squared by 2 into dx. 1 by root 2 pi integral of minus infinity to plus infinity. Now this e power minus t squared by 2 we are taking outside, and here we are substituting x minus it is equal to y, then find dx by dy, so which is 1, so dx is equal to dy. We substitute all these things here, so e power minus 1 by 2 y square into dy. So this integral is root 2 pi. Therefore, e power minus t squared by 2 root 2 pi into root 2 pi. This is equal to e power minus t squared by 2. Therefore, the characteristic function of the normal distribution is e power minus t squared by 2. Next, we find the moments. Already we have discussed, if the lth moment ml is denoted by ml of a random variable exists, so which is expressed by pi l of 0 by I power l. Pi l of 0 is the derivative of the characteristic function pi of t at t is equal to 0. So I write the formula ml is equal to pi l of 0 by I to the power l of pi of t the characteristic function of the normal distribution, that is e power minus t square by 2. So to find m1 we need pi dash of t. So pi dash of t is equal to e power minus t squared by 2. Differentiate the first derivative we are finding here. So minus 2t by 2, e power minus t squared by 2 into 2t. So which is minus t into e power minus t squared by 2. Substitute t is equal to 0. T is equal to 0. Therefore, pi dash of 0 is equal to 0. And m1 is equal to pi 1 of pi dash of 0 by I, which is equal to 0 by I, which is 0. To find m2, we need pi double dash of t. So differentiate this function with respect to t. So we are using the formula uv. So minus t into e power minus t squared by 2 into minus 2t by 2 u dv plus v du. So that is minus t. So here we'll get minus 1. So in this we are substituting t is equal to 0. Pi double dash of 0 is equal to, this will get 0. The first term will be 0 and the second term e power 0, which is 1. 1 into minus 1 is minus 1. So m2. m2 is equal to pi double dash of 0 by I square. So which is equal to minus 1 by minus 1 by minus 1 minus 1. This is equal to plus 1. And find m3. To find m3, pi triple dash of t is equal to, so this will be differentiated. So here already it is pi double dash of pi double dash of t is equal to minus into minus plus 2 will get cancelled. So t squared into e power minus t squared by 2 minus e power minus t squared by 2. This is pi double dash of t. So pi triple dash of t, this function can be differentiated. So t squared e power minus t squared by 2 into minus 2t by 2. UV formula here we are using, and then plus e power minus t squared by 2 into 2t minus e power minus t squared by 2 into minus 2t by 2. So in this we substitute t is equal to 0. Therefore pi triple dash of t is equal to, so if we substitute t is equal to 0, every term will get 0. So pi triple dash of t is equal to 0. Therefore m3 is equal to pi triple dash of 0 by I cube, which is equal to 0. So it is clear that m1 is equal to 0, m3 is equal to 0, etc. So therefore all the odd order, hence all the odd order moments vanishes. Next, so we prove that the even moments, which will be m2l is equal to 1 into 3 into 5 into etc. 2l minus 1. So this we are going to prove. So I write m2l is equal to expected value of x to the power 2l. This is continuous type, so 1 by root 2 pi integral minus infinity to plus infinity x to the power 2l into f of x dx. F of x is e power minus x squared by 2 into dx. And so I will change the limits of integration as 2 into 0 to infinity. Therefore, and also take x squared by 2 is equal to t. So x squared is equal to 2t. X is equal to root 2t. Finding the derivative dx by dt. So that is differentiate this one. 2x dx by 2 is equal to dt. So dx is equal to dt by x. When x is equal to 0, t is also 0. We are substituting here. When x is equal to infinity, t is also infinity. Now, this x power 2l can be written as x to the x squared the whole power l into e power minus x squared by 2 into dx. So now 2 by root 2 pi and L 0 to infinity x squared is 2t power L into e power minus t dt by x is root 2t. 2 by root pi integral 0 to infinity 2 power L t power L e power minus t. This root 2 can be taken outside, and then this t will be t power minus 1 by 2. I am taking this root 2 outside. So here dt. 2 power L also can be taken outside, and 0 to infinity integral t power L, here t power minus 1 by 2 So therefore t power L minus 1 by 2 into e power minus t into dt. And we know the gamma function. So that is gamma n is equal to integral 0 to infinity x to the power n minus 1 e to the power minus x dx. So we compare this function. So here n minus 1, the power of x is n minus 1, here the power of t is n minus 1 by 2. So compare the power. So n minus 1 is equal to L minus 1 by 2 and find n. So L minus 1 by 2 plus 1, so which is equal to L plus 1 by 2. Therefore, this is equal to 2 power L by root pi into gamma L plus 1 by 2. Now, also we know that gamma n plus 1 is equal to n into gamma n. So this is of the form n plus 1. So n plus 1 is equal to L plus 1 by 2. Therefore n is equal to L plus 1 by 2 minus 1. L minus 1 by 2. N is equal to. This is n. So we are writing this gamma L plus 1 by 2 as L minus 1 by 2 into gamma L minus 1 by 2 based on this formula. This is equal to 2 power L by root pi L minus 1 by 2 into gamma L minus 1 by 2. 2 power L by root pi again. This is compared with this gamma function. So n plus 1 is equal to L minus 1 by 2. So n is equal to L minus 1 by 2 minus 1. N is equal to L minus 3 by 2 by 2. Now n is 3, L minus 3 by 2. So this gamma L minus 1 by 2 can be written in the form n into gamma n, but n is equal to L minus 3 by 2. So L minus 1 by 2 into L minus 3 by 2 into gamma L minus 3 by 2. So we proceed in this way. Therefore, this implies 2 power L by root pi L minus 1 by 2, L minus 3 by 2, L minus 5 by 2 and so on 3 by 2, 1 by 2, gamma 1 by 2. This gamma 1 by 2 is root pi and root pi L minus 1 by 2, L minus 3 by 2, L minus 5 by 2 and so on 3 by 2, 1 by 2 root pi. So root pi will get cancelled. 2 power L into this can be written as 2L minus 1 by 2, 2L minus 3 by 2, 2L minus 5 by 2, so on 3 by 2, 1 by 2. 2 power L and 2L minus 1, 2L minus 3, 2L minus 5, so on 3 into 1 by here the denominator we can write 2 power L. This 2 power L will get cancelled. Therefore, it is 1 into 3 into 5, so on 2L minus 1, 2L minus 3 and 2L minus 1. So therefore, all the even order moments are expressed by 1 into 3 into 5 etc. 2L minus 3 into 2L minus 1.